lecture for your own reference. Okay, so again, if you have any kind of doubt, you can ask me. Okay, so I just want to ensure that you understand that there can be many automatas for a single question. Okay, so if I have made this automata, and this automata I think is based on if I just okay, so this automata is based on string length 2. Okay, so it is ending with the AB. Sorry for that. If I just see what we have done in the last one. Okay, so suppose this automata is of length. Okay, so this automata is designed like this, but you can also design it in another way. So it can be possible that my automata is different from your automata. So do not need to worry about it. It can be also correct. So just remember this one point that I add some new section here. So just remember this point that I am want to say to you that for a particular language, okay, so for a particular language, there can be multiple DFA exist. There can multiple DFA exist, okay, but there is only one minimal DFA. Okay, so there can be only one minimal DFA. But what do you mean by minimal DFA? Suppose you have drawn a DFA that contains 8 states, and that DFA can be correct. I am not saying that it is wrong, but there can also exist a DFA that has a minimum state of 7. Okay, so it can also happen. Okay, but this kind of DFA like 9 state 10 states can also exist. There is no need to worry about this, but only one minimal DFA exists that contains the only contains the least number of states. So just remember this. A minimal DFA is always one, but multiple DFA can exist for a particular language. Okay, so if you are able to get at this step, suppose you are coding. Okay, so firstly, if you start coding, you do not need to worry about the time complexity and other things. Okay, but if you get fluent in coding, then we go on and move on to the next step of minimizing the number of states. So if you are at this step, you just need to build a automata that can be any number of states. I do not need to worry about it. You do not need to worry about it right now. Okay, so if you are able to get at this step, there is a simple theorem called a minimization theorem. Okay, so apply a minimization theorem on that. It can be turned into a minimal DFA. Okay, so DFA is much more structured than NFA. Just remember this. Why it's structured? Because I know that the transition symbol is defined. This transition symbol is defined on every state and for every input. Okay, so that is why it is very much structured. Okay, so again, the third question that I will go on, that this says that construct a DFA that accepts a set of string over the length less than or equal to b. Okay, so I just copy and paste it. This thing can also be represented like this. Okay, so it is just saying, just I copy. Why it is not pasting? Okay. So this is the question. You just remember this, that the meaning of this thing is length of W. Okay, so whenever I write this thing, it means the length of w. It says that construct a DFA where w belongs to the input alphabet a and b, and w, the length of w should be less than or equal to 2. Okay, so just you remember the first thing that we have done till now. The first thing is always uh, write a language set. Okay, so the minimum language that is possible over here, it can be a. So this a contains less length than 2. Okay, in the same way a b is also a one length string, so it can be accepted in your language. In the same way a b should also be accepted. Other than that, b a can also be accepted, b can also be accepted, and AA can also be accepted. I don't think there is any other language that has a length of 2. So I think this is a kind of a finite language. So always remember, for a finite language, there can always be a finite automata. Okay, for infinite language, there is a possibility that there can be no finite automata exist. But for finite language, it is always possible that there will be a. Hello.
So do we not need to mention epsilon or pi in the language?
Okay, yes, sure. Because epsilon is a null string, it should also be in the language. That you are correct. Okay, so I'm again mentioning the smallest string as epsilon. Okay, so epsilon has a 0 length, and this length is less than or equal to 2. Okay, you are correct. Okay, so I have missed this. Sorry. Okay, in the same way, just start with the smallest string. So just remember this, start with the smallest string. If you see here, the smallest string is epsilon. So for epsilon to accept, you have to make your initial state as final state. Okay, so this here is your initial state Q naught. I am making this initial state as final state. Okay, always remember, in the case of DFA, more specifically DFA, when you are making a DFA, there can be multiple final state. Multiple final state can exist, but only one initial state. Okay, so start state will always be one. Okay, so if you think about it, we always need to start from somewhere. You cannot have multiple start points. Okay, so if you are also, if you have coded in Java, you will always find one main file. Okay, so it is always one, the entry point should always be defined. So this is like an entry point to it. Okay, so for Q node, if I make the initial state as final state, it means that this Q node is accepting 0 length string. Now I want one length string to be accepted, so I just want this a to be accepted, suppose. So now at this, one length string will be accepted, and now I just wanted two length string to be also accepted, so I just want this AB to be accepted. Okay, so I just wrote this AB, and this AB is also accepted. Now check it, I can make this as AB and AB. Okay, so now the strings that are of two length is also possible. The strings that are of one length is also accepting in this particular automata. Now the third step is to check your uh, transition symbol. Okay, so suppose see here on this, the transition on Q node on A I have to define, transition of Q node on B I have to define. In the same way, transition on Q1 on A has to be defined, transition on Q1 on B has to be defined. Same way, QF, transition of A and transition of B has to be. Okay, so for Q node A, on receiving an input of A on Q node, it is going towards Q1. On receiving an input of B on Q1, it is Q node, and it is going towards Q1. In the same way, on receiving an input of A, it is going towards QF, and it is going towards QF also. So B is also. But now here we have not defined A and B, so that we have to define. Okay, so if I just do a self loop of A B here, there will be one problem that you know, that the strings that are of length more than 2 can also be now accepted. So if I go for this string A, this is 3 length string, it should not be in the language, but if I just draw a self loop here, this A will be in the language. So suppose start with Q node, by receiving an input of A, it is going towards Q1. On receiving an input of A on Q1, it is going towards QF, and on receiving an input of A at QF, it is staying at QF. So it means that this is a final state, and this A string is accepting. So that is a problem here. We do not want this. So what can I do? You remember the concept of the dead state. If I just don't want any kind of string to come after it, I can always do a dead state. It means that after this QF, if any string come, be it A, be it B. So if this comma means a or, okay, it doesn't mean and, it means or. So for one time it can be A, it can be B. Okay. So if any string comes after, so it is saying that after the 2 length is completed, if a 3, the string became of length 3, it will go to a state called QD and it should stay there. Okay, so it is staying there. If you want to ensure, just do a self loop of it. Okay, so now again check the transition here. Transition on QF on A is QD. Transition on QF on B is QD. In the same way, you have to check a transition of QD also. You know this that it is defined here. So transition on QD on A is QD. Transition on QD on B is QD. Okay. So this is the solution to your question, that it should have a length of less than or equal to 2. Okay, so if you can just see the pattern here, that for starting of it has a 2 length. By going further into it, the string length becomes 1 here. In the same way, the string length becomes 2 here. In the same way, if I go further on forward, the string length becomes 3 here. Okay, so it is like saying that this kind of automatas depend upon the number, the length of the string. Okay, so if you are building automata, suppose if I just draw the automata that we have drawn previously. Okay, so just wait for a second. Okay, so if you have seen automata where we have drawn a string length of 2, and another automata, the string length there will be greater than or equal to 2. In the same way, the string length is less than or equal to 2. So this also can be set at least 2, and this can also be set at most 2. It means 0, 1 and 2 should be accepted. It means at least 2, meaning 2, 3, 2, 3, 4, 5, 6 up to infinity can be accepted. If you see the automata here for a 2 length string, that what we have drawn here is something like this. Okay, so if you just uh, uh, open your previous notes, you will find this thing that what I have drawn. It is the same thing that we have done earlier. So this kind of a thing. Okay, so see here for length equal to 2, so this is 0 length string, this is 1, this is 2, and this is 3. In the same way, if you see a length of at least 2, you will find that this kind of automata is drawn in this case. Okay, so what I want, at least 2. After that, any number of strings can come. Okay, so I have drawn like this kind of automata that we have previously done. In the same way, if you see for w is less than equal to 2, right now that we have drawn a automata like this, that all the initial state of string length 1 and all the initial state of string length 2 should be final, because we want one length string as well as 2 length string to be accepted. But after the 2 length string is completed, I just want a dead state, that it comes and just stays there. Okay, so these kind of thing that we have done so far. So if in a case you suppose that this is a 0 length string, this is a 1 length string, it is a 2 length string. Okay, so 0, 1 and 2 length string are 0, 1 and 2 length string are the 0, 1 length, 0 and 1 length string are not accepting here. Okay, so starting from 2 length string, all the length that is greater than 2 is accepting in this. Okay, so see here the number of states. In the same way, see here a 0 length string, 1 length string, 2 length string, and 3 length string. A 2 length string, till 2 length string, the string is accepting. After the, if the length becomes 3, it is going towards the dead state, so it is not accepting here. So if you see that if for two, for if the length of the string is 2, if the length is 2, it is like directly proportional, I want to say. If the length is 2, the number of states here, okay, so if you see the number of states here are 1 2 3. Okay, so if you want 2 length string to be accepted, there are, sorry, 4 number of states. First number of states, second, third, and fourth. Okay, so suppose if again I extend this question to w of 3. Okay, so you will again find that if the length of W is 3, the number of states will be 6. Okay, so if you can again check this, if you if you want to again draw this automata, you will find that the length, for length 3, there will be there will be 5 number of states. Okay, 5 number of states. So for 2 there are 4 number of states. For 3 there will be 5 number of states. Again, if the number of the length of the string is n, the number of state here will be n plus 2. Okay, so this is the formula that we have derived. Okay, always remember that in case that we want the length of the string to be 2, it will always be two states greater than it. Okay, so first state, you know that for for 2 length string we have to draw like a three states. Okay, so one state extra is for a dead state. Okay, so if you see this, there are two, the length of the string should be 2. For till here we have drawn 2 states where 2 strings are accepting. Okay, so one extra state, 3 states, sorry, I just want to say that for 2 length string I have to draw 3 states. Okay, so this is 0 length string, 1 length string, 2 length string. Okay, so you know that after the 2 states, I do not want anything to be accepted. So third state is for a dead state. Okay, so if the length of the string is 3, I have to draw 4 simple states and 1 dead state. In the same way, if the length of the string is 4, okay, so if the length of the string is 4, I have to draw a 5 simple state and plus 1 dead state. So that is why it is always if the number of the length of the string is n, the number of states is n plus 2. In the same way, if you journalize this also, okay, so this is directly proportional to the length of the string. So these questions are directly proportional to it. Okay, so if I say that w, if I given you like this question for 2, the possible strings is 3. So for if w is greater than equal to n, the number of states will be n plus. Okay, so you can try this. You just do w greater than equal to 3. You will find the number of states yourself. Okay, so if you want to do more practice, that is your question to do it. Okay, so if I do this, it will be a number of states again will be n plus 2. Okay, okay. So if you have any doubt, you can ask me here. DFA like automata represented by hardware or programming. Himanshu, DFA like automata is always represented by programming, but you can also represent it by hardware. Okay, so I will tell you how what hardware is available, but mostly in most journal cases we always implement DFA by using a programming approach. Okay, okay. I think if you have understood this now, just try the next question yourself. Okay, so I will give you like 2 or 3 minutes. I think you can easily do this question. Okay, this question is just say that construct DFA that accepts a set of all string over AB such that the length of each string is even. Okay, so it can also be written like this, that if I just copy and paste it here. It can also be written like this: constructor DFA where W belongs to AB and W mod 2 is equal to 0. Suppose so the length of W is 2. So 2 mod 2 is again 0. 0 mod 2 is again 0. Okay. So 4 mod 2 is also 0. Okay, so it is saying that when the length of the string is even, then the length of the string is even, and if you take a mod of this, it will be 0. So it is just like saying that the length of each string is even. Okay, so it can also be represented in the language that is written here. Okay, so just try it for 3 or 4 minutes, and please post your automata that you have drawn. Okay, just take like 3 minutes. I can think you can easily do this. Okay, just remember the step. First you have to write the language. Second, you have to draw a rough skeleton based on the smallest string. After that, you check for the transition symbol and design the automata accordingly. Okay, so try it. Okay, so Anushka has drawn a right automata. In the same way, Fanindra also drawn the right. Mayank has drawn a automata in the minimum number of states, so it's also right. In the same way, Dhamrilla, again, that the automata is again right here. Okay, so Shrikant, there is just a one problem, that at the start state you cannot give any input. Okay, so at the start state, the input is always a zero length string. Okay, so just remember this thing. Otherwise, your automata is right. You do not have to define the strings on the start state. Okay, so please write arrows also. I do not know where your automata is going. Okay, otherwise it is correct. Okay, so if I just say that again, the first step is to write the language here. So the language here is again even length string. So if I draw even length string, you know that this is a even length string because zero length is also a even length. Okay, so you know null string will also come in the same way. A two length string uh, will also come bb. Okay, in the same way, four length string will also come like A, B, B, A, B. Okay, so it becomes your infinite set. Okay, so firstly, if you think about it, that what can I draw an automata? Suppose this is your first state. I know that it has to be a final state because of this null string. Okay, so if I want my null string to be accepted, that the initial state will be a final state. Okay, so that is why I have drawn this like a final state. In the same way, go for a two length string. Zero length string should be accepted, so it is accepting. One length string should not be accepted. Okay, so one length string should not be accepted. Two length string should not be accepted. Two length string should be accepted, so I am writing it like that. Two, that q, two. Again, if you go in this direction, that q, three length string should not be accepted, four length string should be accepted. Okay, in the same way you can go for any number of times, but what happens here, that it again becomes an infinite automata, so I do not want that. Okay, so if I go like this, that the I want the zeroth, I just making the even number state as sorry, 0 1 2. Okay, so this is 0 state, 1 state, 2 state. So I'm just making the zeroth even number state as a final state. Okay, so 3 4, again I am making a 4 and 6. So it can go on like that, but it will not become finite in any case. Okay, so just remember that take the smallest string that I have told you the method here. Okay, so the smallest string here will be your epsilon. After that, I want a to be accepted, so I just draw input skeleton like that, a. Okay, so a is accepted here. Now I just need that only even length string should be accepted. Okay, so if I just go back from here, if I just write like AB here, AB here, and BA here. Now again check it, zero length string, a zero length string, one length string, two length string is accepting, three length string, four length string is also accepting, five length string, sixth length string is also accepting. So it is a correct automata. This is a correct automata. There is no, there is nothing wrong with it. Okay, so just remember this. This is correct. Okay, so in if I just order to minimize it, I can see that on Q node, if I just draw automata like this, a small b, and this initial state should be the final state. Okay, so it is inputting a there. just if I just again draw it, so suppose, so this is q naught, and the initial state should be final state to accept the zero length string. In the same way, just so in the same way, if I just do this a b and it doesn't go anywhere, so this now this becomes our one length string, and this is your zero length string. If I just go again and put it to backward like this a b, now here it becomes two length string, Now 2 length string is accepting. Here it is 3 length string. So three length strings are landing on Q1. In the same way, 4 length strings are again landing on Q node. So it is again accepting. 5 length string is landing on Q1. Okay. So this is correct, plus this is the minimal automata, minimal. Okay, so I think you get the point. So you do not need to worry about it if you drawn this automata. Okay, so just to see this automata is correct, but this is the minimal automata. Okay, so now you will be able to find the various kinds of pattern that how can you make an automata minimal. Okay, so if you know, if you do not, if you now cannot do this, do not worry about it. We will do a simple algorithm. That algorithm like take 2 or 3 minutes to convert like four this 3 states into 2 states. So do not need to worry about that. Okay, so the next question is fairly simple. I now think you can easily do this. The only one thing is changed here. It is saying that even length string have done. Okay, so I just need a odd length string. If the length of the string is odd, then we want that that automata. Okay, so just keep in mind that what is the meaning of there. It says that constructor DFA where W belongs to A and B, and the length of W mod 2 is 1. Okay, so 1 means that if the length of if the length of W is 1, if I do a mod 2 here, it is 1. In the same way, if the length of string is 2, it if I do a mod of here, it becomes 0. Okay, so if I do a length of mod 3 mod 2, it becomes 1. Okay, so it means that all the odd length strings, if I do a mod of it, it is always 1. So it is just saying that it should accept a string length of odd here. Okay, so just try it. I will tell you the answer in just 2 or 3 minutes. Okay, I think you can easily do this. It is not a very difficult question.
Sir, you are muted.
Yes, I have muted myself for you to try this automata. Okay.
Okay, sir.
Okay, Mehak, exactly. You've drawn the right automata. Mayank has also drawn a correct automata. In the same way, Fanindra has also drawn a correct automata. Okay, so now you get like a feel how to draw this automata. Okay, so again the first step, you know, again Chahat has also drawn the correct automata. So well done. That okay. So if please try to draw as much automata as possible. Like if I have said in the starting lecture of this that I have said if the length is 2, the number of states will be 4. Okay, so you can also try the length for 3. Okay, so 3, 4, 5 and see the validity of the formula that this formula is correct or not. Okay, so by doing more and more practice, you can easily recognize that what string will go in what states. Okay, so again, I want I that the I am defining is just just a many steps of it. Okay, so if you have done more practice, you will know. Again, you can draw automata in your own mind only. You do not have to take up your pen and pencil. If you have done enough practice, you can only draw automata in your mind. So okay, so the first step, again, remember, the first step is always to draw a language, and that language will contain only odd length string. So it will be a b a a uh, a b a, and a 5 length string, and 7 length string, and infinity. Okay, so this particular language is of infinite nature. Okay, in the same way, if you draw automata, if you have seen the previous automata that we have drawn, it is just take the uh, first state. Now this first state is a 0 length string. Now q node is a 0 length string. We do not need we need Okay, so 0 length string is a even length string. We do not need to accept even length string, so that is why I'm not making q node as a final state, but we want one length string to be accepted. Okay, so for one length string I am just drawing the final state. Okay, in the same way, this a is a one length string, b is also a one length string. If I do this again, a and b is now here, the it is a one length string, it is accepting. Here it is two length string, and it is landing on q naught. So two length string is not accepted, so that is correct. We do not want even length string. In the same way, if again two go here, it becomes three here, so three length string is again accepted. In the same way, four length string is again landing on q naught, so we do not need to worry about it. So that is a correct state of automation. Okay, so if I check the input q node transition symbol again, so this seems like a silly step, but please, if you do this again and again, you will never draw a wrong automata. Okay, so if you check this step again and again, you will never draw a wrong automata. Okay, so I just write this for your reference, but you can again check it from just going into the state. So for q naught there is a transition of a and b, I just know. For qf there is a transition of a and b, I know. Okay, so you do not have to write like this. It is just for your reference that you have to check, but otherwise this step takes only 1 or 2 seconds to check and see that the transition of every input is defined on every state. Okay, so moving on further, I think now you have get I think now you can easily be able to do these kinds of question. Okay, now see this question. I just completely gave up the English language notation. Now I completely transformed into this notation. Okay, so it is saying construct a DFA where W belongs to AB, and the length of W mod 3 is 0. Okay, so if I say the length of W is 1, so 1 mod 3 is 1. So I do not want this. If I say 2 mod 3, okay, so if I 2 mod 3 is 2, but 3 mod 3 is 0. So by the meaning of it, I want 3 length strings. Okay, so just try this. If you have done 2 length string, I think 3 length string is fairly easy. Okay, so just try it. I will just tell you the solution in like 3 minutes. Okay, so just post your answers in the chat box. Okay, Amit answer is also right. I think this is the previous question. Amit, well done. Okay, so just keep in mind that if I do a 0 mod 3, for 0 mod 3, it is also 0. So 0 length string will also be included. Just keep in mind that. Okay. So Anushka has done right, but just need to make the first state as a final state. Okay. Otherwise, it is correct. Phnindra has drawn a very good automata. I think that is the most efficient one till now. It only contains 3 states. Okay, so that is correct, Phanindra. Mehak Kapoor has also done a right automata and it is also very efficient because it contains only 3 states. Okay, so I think now you are getting uh, the point that what I try to say here. Always try to make your automata as minimal as possible. Okay, so if you are drawing automata that Anushka has drawn, that is it is not a wrong automata. Okay, so if you have seen in your chat box, Anushka has not drawn a wrong automata, just it contains a more number of states. Okay, so if you see at this question, I am only saying construct a DFA. I have not said construct a minimal DFA. Okay, so I have not said. Okay, so most of the question that I will be giving to you that is will be based on this construct a minimal DFA, because in your evaluation I cannot check that what have you drawn. So everybody will get a different number of state, but for a minimal automata everybody will get only one correct number of states. So that is why I will tell you that what is the concept of this minimal, so you do not need to worry about it right now. This is a very simple concept. I'm again saying it that this is a very simple concept. Okay, so just go, if you look at the question that W mod 2, it is kind of a similar question. Okay, so just know that you can again wrap the loop at the first state. Okay, so you know this that the language, the first step is language. So 0 length string or 3 length strings A, B, 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 and 6 length strings A, B, 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 A, B, A, B, A. So these 6 length string, 9 length string, 12 length string will always be there. Okay. In the same way, now start because for the we want this null length string to be accepted. So just draw the first state as your final state. Now we know that this epsilon is accepted here. Again, go for the minimum string. Okay, so you can go for it again. A, this is q1 and this is like again put it as a. If you see now, if I just go towards the back automata that I have drawn, you can again add the first state, or you can go towards the back of it at the final state. Again it will result in the same thing, that I want to minimize the number of state. Okay, so if I just go towards back here, now 3 length strings are accepted here. Okay, so if I just write A and B here, A and B here, A and B here, so you can easily see that 0 length string, 1 length string, 2 length string, 3 length string. So 0 length string is accepted, 3 length string is accepting. So here right now 4 length string, 5 length string, and again here will be 6 length string. So 6 length string is again landing on Q node. So it becomes so similar to the question that we have done earlier. Okay, so I don't think you will have any kind of doubt here. If still you have, you can just easily tell me here. Okay, in the same way, seventh question you can also do it. I just want to ensure that you are understanding it. That is why I have put like 15-14 question for practice of this DFA. Now you can take up any textbook, and that textbook can be easily understood by you, because you have understood the basic notation as well as to how to draw a basic automatas. Now you can take any book, that book is easily understandable. So just try this. I will tell you the solution in like 2 minutes. Okay, automata drawn by Fanindra is again correct. Okay, so Abhimanyu, yes, Abhimanyu, it is all again correct. You're also correct. Abhimanyu has also drawn right. Mehak, okay. So Mehak, this states can be decreased. Otherwise, this is a correct automata. Okay, so this states can be decreased. Okay, so the minimum state will be if for one. Okay, so I want. So the minimum state will be one. One length string is not accepted. Mehak, in your automata, one length string like A and only B is not accepting. So please just take a look at it. Mayank. Okay. So if I again draw the automata, so the first step you just remember, always remember, is to write a language. Okay. So if you do not write a language, you will always get confused. Okay. Uh, okay. So Anushka has also drawn the right automata. Okay. So well done. uh, in the same way, just go for it. So where I will get a right, where I will get this 1 mod 3 is 1. Okay, so 2 mod 3 is 2, 3 mod 3 is 0. Okay, so I do not want this, but 4 mod 3. Okay, so 4 mod 3 is 1. In the same way, 5 mod 3, 6 mod 3, I want 7 mod 3. So the string is going like this: 1 4 7 and 10. So it is going like this. Okay, so one length string like A B should be accepted, 4 length string A B B B B. Okay, so it can go on to infinite set. Okay, so firstly take a look at the smallest string. Now you know the smallest string Q. Smallest string is A, so I'm just drawing a here. So it should be accepted as a final state, so it is accepting A as a final state. Okay, so again I want a 4 length string. So what do I do? 0 length, 1 length, 2 length. Okay, so if I go for 2 length here, it will be, if I say anything A, so right now it will be 2 length. Now I want 3 length, 4 length. Again, if I just go back from here to here, now it will be a 3 length. Till here it will be accepted as 4 length. Okay, so this is the minimum path that I can take. You can again go towards the end of it, again draw another state. You can do it, but this is the minimum path that I can take that accept this string. Okay, so check this. Starting here we are landing at 0, here we are landing at 1, here we are landing at 2. Okay, so here again we are landing at 3, here we are landing at 4. So we want 4 length string, so it is accepted by this state. Here we are landing at 5, again 6 and 7, again we are landing here at 7 length strings, so these are also accepted. So again just put a b and a, again put a b and a. So check the states here. So on q node a and b is defined, on qf a and b is defined, on q2 a and b is defined here again. Okay, so this is the minimal for finite automata that can be possible for this question. Okay, so again take, if you clearly take a look at it, so this is very important point. Okay, where the mod is 3, now the minimal number of states, if you see here, is again 3. Okay, so if you see here, this is 3. Again go towards the previous question. If the mod is 3, again see here the number of states here, the minimal number of states is 3 here. Okay, minimal states, so again it is 3 here. If you go towards the again previous question, if the mod is 2, the minimal number of state here is 2. Okay, so just this is like we are recognizing the patterns here. Again the mod, if mod is 2 here, the minimal number of state is 2 here. Okay, so 2 minimal number of state. So if I just journalize it, if I just journalize it to like, suppose I am saying that string length w mod n is equal to 0, then the number of states, minimal number of states will be, you know it will be n. N. Okay, so in the same way, w mod n equal to 1 also, sorry, w mod n equal to 1 also. In this case, the number of states again will be n. Okay, so seeing by this pattern, this can also happen. You can try it for another things like w mod 3, w mod 4. If you see this question, you will find the number of states, minimum number of states will be 4. So this is kind of, we are recognizing the pattern from the built automatas. Okay, so okay, so your class time is over. Okay, so if you have again any doubt, you can tell me in the chat, or you can just unmute your mic and ask me. Okay, so I think you have understood that what I have taught. If you have any doubt again, okay, so I think you can go to the next class. Today's lecture is over, so thank you for listening. You can go towards the fine again
Thank you.
next class.
Thank you. Thank you, sir.
You're welcome.